Hello there, Mr. Sutton here with the IM23 Honors 3-7 homework solutions on circle segments. For number 1, we're trying to find the value of x in here. Now, since we've got two chords bisecting each other, we know that the product of these segments, so 10 times x and 6 times 7, those products have to equal each other. So we can write 10x equals 6 times 7, or 10x equals 42. Dividing by 10, we get x equals 4.2. For number 2, we're trying to find the value of z here. We know that z squared is going to equal the outer segment over here times the sum of the two segments, so 6 times 8 plus 6. So that's going to be z equaling whatever 6 times 14 is. So let's see, that's 84. And we just have to square root that. And we're going to put this in simplest radical form. So we can split this up into square root of 4 times square root of 21. So 2 radical 21. For number 3, we're trying to find the value of z in here. Since these are two chords, we know that 10 times z is going to equal 6 times 8. The products of the segments will equal each other. So we've got 10z equals 48 then. So z equals 4.8. For number 4, we have a tangent and a secant line here. So this is going to be c squared equals a times a plus b, or 4 squared equals 3 times y plus 3. So we've got 16 on the left and 9 plus 3y on the right. Subtracting 9, we got 7. Dividing by 3, we have y equals 7/3. For number 5, we've got two secants involved in this problem. So we can do a times a plus b, or 10 times 10 plus 10.7, equals 11.5 times x plus 11.5. All right, so we're going to simplify a little bit on each side. So over here we've got 10 times 20.7, which is 207. On the right side, we've got 11.5x plus whatever 11.5 times itself is, which if you do the calculator comes out to 132.25. Next, we got 207 minus 132.25, and that's going to come out to 74.75. Next, dividing that by 11.5. So divide our answer by 11.5, we get an answer of 6.5. So there's our x value. For number 6, we've got two secants. So we're going to do 5 times 5 plus x equals 6 times 6 plus 6. That'll be 25 plus 5x equals, let's see, this is 6 times 12, so 72. Subtracting 25, that's going to be 47 on the right side. And dividing by 5, that comes out to 9.4. For number 7, we've got two chords intersecting each other. So we're just going to set the products of their segments equal to each other. So we have 11 times x equaling 8 times 5. So 11x equals 40. And then we can just write x as 40/11ths. For number 8, we've got two secants. So we're going to have 10 times y plus 10 equals 9 times 18 plus 9. So that's going to be 10y plus 100 equals whatever 9 times 27 is. And that happens to come out to 243. That's really 3 squared times 3 to the third. 3 to the fifth is 243, if you weren't using a calculator there. Subtracting now, we've got 10y equals 143. And dividing by 10, that comes out to, let's see, you could do 143 over 10 or 14.3, either of those. For number 9, we have a tangent and a secant. So we can do c squared equals a times a plus b. So 5 squared equals 2 times 2 plus x. So we've got 25 on the left and 4 plus 2x on the right. We subtract 4, we've got 21 equals 2x. So x then is going to be either 10.5 or 21 over 2, either way. For number 10, we've got two secants. So we'll do the outer segment times times the sum of the two segments for each of these and set them equal. So we can write 3 times 3 plus 6 equals 2 times 2 plus x. So that's 3 times 9, or 27. And over here we've got 4 plus 2x. Subtracting 4, that's 23. Divide by 2, that's going to be 11.5, or 23 over 2. For 11, we've got two chords, and we're trying to find y. So we can use the AB equals CD thing, where you set the products of the segments equal to each other. So we can write 2 times y equals 3 times 4. So 2y equals 12. So y equals 6. For number 12, we can use c squared equals a times a plus b, because we have a tangent and a secant together. So x squared equals 3 times 8 plus 3. That's 3 times 11, so 33. And then we just take the square root of that, so radical 33, final answer.